Okay, good morning. Welcome to you.
Well, it was GreatMath30.
Great math number 30. So this is an old Moem's problem that gave you a little bit of trouble this morning. It says Sarah places 4 books on a shelf. The blue book must be somewhere to the left of the green book.
So blue has to be to the left of green.
Okay, so we need blue to be to the left of green. And the red book must be somewhere to the left of the yellow book.
So like this.
Okay. In how many different orders can Sarah place the books on the shelf? Okay, so what did you think the answer was?
Well, 16.
16, okay. And what was the answer?
I think it was 6.
I think it was 6, okay. I haven't looked yet. But let's see if we can figure out what's going on here. So we have the blue book has to be to the left of the green book, and the red book has to be to the left of the yellow book. So we've got some examples. So why don't you give me an example of one that works here? Why don't I make sure
This.
what we're doing is on camera, since
This
it's not.
works.
Okay.
Blue book's to the left of the green book, and the red's to the left of the yellow.
All right, that's one. That's one that works.
You could also switch them around, so you could say red and yellow, blue and green.
Okay,
Do this.
good. All right.
Let's see.
Are you sure that's right?
This we have to flip these.
Yeah. Now the blue is to the left of the green.
And there's also something else we can do here.
All right. What else could we do?
We can do this. Because the red book's still to the left of the yellow book, and the blue book's still to the left of the green book.
All right. Why don't you make a new one rather than switching that one? So why don't you make a new one?
Okay, so you have yellow, green, red, blue.
Okay.
So far we have 3.
All right. So interesting. So how can we approach this systematically now that we see some of the options?
So you can kind of, I think we should find 3 of them, and since you can switch the pairs of books around, you just need to double that.
Ooh, interesting. Would that work with these two? Can you double those two?
Well, you can't really flip them. You can't flip them.
What's the problem when you flip the ones in this one?
They, like, the red, it actually makes this, it makes this one.
Yeah, so you're kind of on the right track about making them. You just have to be careful about doubling them because you might accidentally overcount. So we do want to try to find some sort of systematic way of counting.
Well, we can see how many books like can go in the first slot, second slot, the third slot, and the fourth slot.
Okay, that's a very interesting thing. Okay, so which books can go in what you're calling this one the first slot?
Yeah, this one's first, second, third, fourth.
All right, so how many different books can go in that slot?
Well, let's see. I think there can be 4 books,
All right.
because any one of them can go here.
All right, so show me an example with a blue book in that slot.
So, well, the blue can't go there,
Why not?
because the green book, it has to be somewhere to the left of the green book. So it looks like only the green and the yellow can go here. So it's 2 slots here.
Okay, so that does give us maybe an idea of a systematic way to count.
And if you now you can have 3 in this slot because you used one in that slot.
Okay, maybe.
So 3, and then you can have 2 in this slot, and then you only have 1 book left.
Okay,
So
maybe.
2, 3, 2.
Maybe.
Yeah.
Maybe. All right.
So 2 times 3 times 2 is 12.
Okay, and what did you think the answer was?
16.
Okay.
The actual answer was 6.
Yeah.
So it seems like we're over counting. How can we divide this by 2?
Yeah. Let's go move on to the second part, okay?
Okay.